Good evening. Welcome to Community and Technology, where we connect the global community with news, information, and resources that we hope will help improve your life. I'm Stu Reid. I'm here with my co-host, Dave Burstein. Hey, Dave. Today, we have a very special guest, Professor Julia Stoyanovich. Julia is an associate professor in the Department of Computer Science and Engineering at the Tandon School of Engineering and the Center for Data Science at NYU. Professor Stoyanovich's research focuses on responsible data management and analysis practices, on operationalizing fairness, diversity, transparency, and data protection. She serves on the New York City Automated Decision Task Force by appointment by former Mayor de Blasio. Julia holds an MS and PhD degrees in computer science from Columbia University and a BS in computer science and mathematics and statistics from the University of Massachusetts at Amherst. Julia, welcome to Community and Technology.
Thank you so much for having me. Looking forward to the conversation.
Yes, absolutely. So, we've talked about automated decision making quite a bit on our show, but just for new listeners who maybe are unfamiliar with it, can you just give us a brief background? What is automated decision making and why is it important?
Thank you for that question. So automated decision making or automated decision systems are systems and practices of using data and algorithms, various types of algorithmic tools, to assist people in making different kinds of decisions. And these decisions range from, let's say, government decisions about how to allocate resources, to a bunch of decisions in industry, such as to whom to show what particular ad, or what sort of a strategy to devise for the way in which you deploy your Uber cars, or where you place your bicycles. And also automated decision systems are used in domains like medicine to assist, for example, physicians in diagnosis and prognosis of various diseases. So these systems are essentially as widespread as is data and computing tools.
And you've made a study of its impact, and tell us a little bit. I've read a number of your articles in Wall Street Journal and other places that talk about its uneven impact, disproportionate impact on women and people of color and other underserved, marginalized populations. Explain how that happens and what that issue is.
Sure. So I'm a computer scientist and a data scientist. And in data science in particular, we like to learn from examples. And so one specific example, a very important domain where automated decision systems are used and that I have been very interested in, is the use of these systems in hiring and employment. So all of us at some point likely are going to apply for a job or have applied for jobs. And it used to be the case that you submit your resume and then a human looks at your resume and decides whether or not to invite you for a job interview. And then you come in for a job interview, and again, there's a human speaking with you, assessing how well suited you would be for that particular position, whether you're qualified, et cetera, et cetera. But these days, as anybody who's applied for jobs likely will know, or at least guess, many of the steps in this hiring process are automated. So if you submit your resume for consideration for a position, more likely than not, it's going to be screened by a machine that is going to read the text of your resume. And based on that, it will make predictions about how well qualified you would be for a particular position. And even before you apply, frankly, there is the stage in the so-called talent acquisition pipeline called sourcing, where recruiters are going to go out and search for candidates based on some information that is available about them, for example, on LinkedIn. And that is also, of course, automated, right? Because the way that this search happens is assisted by tools that are broadly used, like LinkedIn Recruiter. And already the decision about whom to approach for a particular position, who may see an ad for a particular job, is going to be impacted very heavily by data and by algorithms. And so sourcing I discussed just now, then resume screening is another point where machines are used. once your resume, let's say, passes that initial filter of perhaps you're qualified, you may be asked to submit a recording of yourself answering some standard questions. And this could be a voice recording or even a video recording of yourself responding to these questions. And then these interview responses will also very often be processed by software. And so it is only at the very end of this process that an individual would in fact be able to see a human. And so what we worry about with the use of these systems in an important domain like algorithmic hiring is that if these decisions go unchecked, if they rely solely on the data that we have about what the workforce looks like today, about what kinds of demographic groups are well represented or not so well represented, say in technical roles or in executive roles. In other words, if we rely on the data exclusively to guide us how we decide about the workforce of tomorrow, then we will likely be replicating the kinds of biases and the kinds of discrimination that we have been exercising in our world up to now, because the data on which these algorithms are based is a reflection of that world, right? So what we do then is it's a kind of a self-fulfilling prophecy in a way, right? Is that we replicate today into tomorrow, and we legitimize this replication by saying the machine said so, right? It's objective. It thinks you're qualified, or it doesn't think you're qualified. So therefore, there you go. That's the outcome.
Let's ask the hard question. How biased is this hiring process today?
That's an excellent question. And it is one that I, as a researcher and as a member of the public, would really love to know the answer to. And we have evidence of different types of bias exhibiting itself at different stages of the pipeline in particular use cases, but we don't have a complete picture of this because at the moment, companies that are using algorithmic tools to screen applicants and to make these very impactful decisions are not compelled to disclose either to the applicants or to the public at large that they are in fact using algorithmic tools. So that survey at the moment is out of reach. And yet we have lots of very worrying signal. We have lots of very worrying observations that make us think that we should really be digging deeper and opening up this black box.
Let me give you a reason why from my personal experience. This is 40 years ago, but some things haven't changed. I was earning my living programming computers back then, and I got called in by a big executive recruiter agency who wanted to put all the resumes on the computer. It was pretty early for that kind of thing then, so it was an interesting job. And then they went through they systematically would take all the job referrals they get and run it against that database. Against, is somebody a menswear buyer? Have they traveled to China, which is a big issue in textiles, which is where they specialized? And there were two questions in there, one of which I should have knocked out or resigned at the point. But I was young and I didn't think about it so much. It was age. And it turned out when we looked at the first few dozen requests that came through, almost all of them said they wanted somebody under 40 or under 35. And they were just screened right out automatically. The exception, incidentally, was high-level positions where they would hire senior executives who were 50. But for mid-level positions, if you were over 40, you'd be eliminated from most jobs. Now, that was deliberate discrimination. I should have recognized at the time I should have walked out the door, which I had to do a few months later, because of the other thing that was in that database. In that database, there was a field for race. And I said, do we really want to ask that? And they said yes, because they were getting jobs that wanted to go out of their way for affirmative action and find somebody who wasn't white. So I was, so the people I was working with said, oh no, leave that in, that's good. How much of that do you think is happening now? Any way to guess?
Yes, a lot of that is happening now, and unfortunately, right? And there have been fairly recent reports of direct and deliberate discrimination of the sort that you're describing, where an employer would be able to directly target ads for jobs, let's say by gender or by location, which in this country, as we know, is very much a proxy for someone's ethnicity and race. And these situations definitely do arise. And one of the issues with the use of algorithms in this space is that it can be fairly easy to hide them, because you can hide behind proxies. Something like, oh, maybe I don't want to target ads directly by, let's say, gender, but my algorithmic system is going to pick up whether somebody went to an all-women's college or whether there's just the word women's mentioned in their resume. And then these candidates would be downgraded, not even deliberately, but simply based on the fact that in the past, this particular company or this industry hasn't been hiring people who were women or who went to all women's colleges. And so they would be deprioritized. And the reason I'm bringing up that specific example is because there was actually in 2018, I believe, a revelation that Amazon built with a lot of effort and a lot of investment, a resume screening engine. And their stated goal was, in fact, to improve the diversity of the workforce. But then it was determined that this engine was picking up exactly this signal, that it was downgrading resumes that mentioned things like chess club captain, women's chess club captain, rather, or all women's college. So yes, these situations do arise. There are cases of deliberate direct discrimination on the part of employers, on the part of hiring agencies, as far as we know. And there are also very widespread effects where proxies play a role in this. Now, this other point that you brought up is actually very interesting about whether or not we should be using information such as gender and race if we were to enact an affirmative action style intervention. And there isn't a really clean and clear answer to this. So in the United States, there are two competing doctrines that we have on the books that both aim to make it so that we don't discriminate in these very important decisions like hiring, like access to credit, like access to housing. But operationally, they are at odds with each other. One of these is the doctrine of disparate treatment that tells us that we cannot use protected characteristics like gender, race, age, disability status to make individual level decisions. The other doctrine, though, is the doctrine of disparate impact. And it says that when we make these decisions for a population, we have to make sure that we don't systematically discriminate against members of disadvantaged, historically protected groups, like women, like older people in hiring, like individuals with disabilities. And so you see that these are at odds, right? One of them tells you not to use, let's say, race or gender, and the other tells you to try and guess at the population level what was the demographic breakdown in terms of race and gender of all the applicants, so that you can say at the end of this process that there weren't any group level disparities. And this debate is not something that we are going to have a definitive answer to. Should we or should we not use gender or race? The biggest question here is about how do you use these, and what are the benefits of using or not using these attributes, and what are the harms, and to whom are these the benefits and the harms. And that essentially goes right into this data and algorithm ethics conversation that is very difficult and then very interesting to have.
It sounds like, Julia, the first issue is a policy issue. What is it we're trying to achieve? And the second issue is perhaps a disclosure issue as to how are these AI systems impacting folks. You may have a policy of inclusion or exclusion, but it sounds as though some of the AI systems, we don't even know how they are operating to exclude or include it. It's implicit. Is that correct?
That's right. Yes, that's right. So I think that policy is, frankly, it's no different. I mean, these are all tools in the toolkit that we have, right? Policy interventions, technical interventions, rules and regulations. These are all tools that we have at our disposal as a society and also as individual employers, let's say, right? To make sure that the way that we use our decision-making, algorithmic or not, is making the world a better place, presumably, or is making a world such that you can operate your business effectively. And these could be competing objectives. But you're absolutely right, Stu, to say that the fact that we use data and algorithms to make these decisions now, that it makes things more complicated. It makes things more opaque. And what it does in particular is that it shifts seemingly this burden of responsibility for any mistakes or for any decisions that lead to a lack of equity from an individual, a person who is a decision maker, and onto this presumably, seemingly objective technical black box. And this is the most troublesome thing here that's happening, is this shifting of responsibility that we should really not allow to happen. Because ultimately, it is a human's responsibility, and it's a responsibility of groups and of societies to make sure that we are accountable in the way that we make decisions, algorithmic or not.
You had a very interesting suggestion on how to combat this, that companies should put all their criteria up front for applicants. And then if somebody was refused, explain to them why. The second really fascinated me because that could help people to guide them for the rest of their job search and find out what was going on. Talk to me about how that might work.
Yes, absolutely. Thank you for bringing this up. So the intention of public disclosure, and here we're talking about algorithmic hiring specifically, and about telling people upfront before they apply what criteria and what screening methods even will be used to screen them. And also after a decision was made, telling them why they did or did not make the cut. So there are, and I like to call these public disclosure devices nutritional labels, because I think that that makes it somehow immediately clear that there is this intention of consumer protection and of giving people actionable information that would then inform their choices, right? The way that they behave. So with the nutritional label that is attached to a job posting before somebody applied, what the person is able to do is to see how good a fit they are for the position. First of all, do they even have a shot, right? And also to decide whether or not to apply for reasons other than qualifications, perhaps. So let's say that a company is using something like an automatic personality test as part of their screening. I might object to that practice just on the basis of objecting to the notion that personality is a valid construct that should be used for the purpose of hiring, right? And then I will withhold.
Let me come in there briefly.
Yes.
Okay, because you're being polite.
Uh-huh.
What's pretty clear when you look at any psychologist looking at these things, most of the personality tests are something I can't say on the radio.
Well, I can give you a phrase actually that you can say on the radio. I mean, a lot of this is borderline race science, right? A lot of these types of tests are borderline eugenics. And as an academic, I have no problem saying this, because this is actually something that I believe, right?
And somebody went back, I'm not remembering all the details, and found that the Nazis were citing these American social scientists and university presidents to explain what and why they were doing.
That's terrible. That really is disturbing. And unfortunately, you see these phenomena, they don't die. And now they are showing their ugly heads in this sort of objective technological box. This should bother all of us.
Yeah, break that down for us, if you would, Julia, how the eugenics of some of the psychological approach, how does that work? And how does that negatively impact folks of color and others? Break that down for us, if you would.
Yeah, so I have to say that I'm not myself an expert on eugenics, right? I'm a data scientist. As a person, I have, of course, a very negative opinion on this. But the way that my colleagues and I have approached dismantling these methods has been not by saying that, in principle, what they are doing is wrong. Of course, we don't endorse that. But there are also ways to dismantle these constructs with the help of data science tools, believe it or not, right? So one of the things about methods like those that are based on eugenics is that they are just junk. They actually do not predict anything meaningful, right? And very often these tools, these personality measurement assessment instruments, they disagree with themselves. So I just think that calling them on their nonsense, and I would have used a different word if we weren't on live radio, is actually very effective. So suppose that you're applying for a job and your potential employer is using a personality assessment tool that takes as input either your resume or your LinkedIn profile. And in fact, it tells you, I can take your resume in whatever format that you like. Give it to me in PDF, give it to me in Microsoft Word, give it to me in raw text. I will be able to construct your personality profile from that. I'll tell you how conscientious you are. Here's a score from, I don't know, 1 to 10. How much of a team player you are, etc., etc. Now, that, of course, to anybody reasonable, I think that doesn't seem like that's possible even to do, right? But so we did a couple of experiments where we took a bunch of these tools and we ran some resumes through them in different formats. So it turns out that for some of these tools, if you run the same content, literally the same resume, but in different formats, like I believe it was PDF versus raw text, it would give you a different personality profile sometimes. Yeah. So this is not even anything to do with gender or race or intersectional discrimination. It's just nonsense, plain and simple, right? So I think that there are lots of opportunities for us to just call them out on what they are and laugh about them together. And then maybe some companies will go out of business, but good riddance, frankly.
Yeah. Now, Stu and I are both involved in a large nonprofit, and which has about 100 employees. And I don't think their hiring has been very good, not for the reasons you're thinking of. You made some suggestions on what an organization should do. If I was recommending to the board of that organization how they could change the hiring process, what would you recommend?
So again, I'm a bit out of my depths here, right? Because I'm not a hiring professional, nor do I have a lot of experience really hiring people in a business setup. But I would just say be human about this. I mean, you are hiring a peer for yourself, not only because they currently have the types of qualifications that you want, but also because you want to give people an opportunity to grow and to develop together with your company, to shape your company's culture. So don't think that there exists this perfect person who is going to be your perfect unicorn employee whom you can hire and then everything is just magically working out, right? It's your responsibility to find people and to educate them, to mentor them, to tutor them, to become part of your organization. And so I think that breaks down that entire narrative, frankly, of, we look for the very best candidates available now. Once we found them, we're all set. It's a similar narrative with diversity hiring, by the way, right? I mean, pretending like by simply hiring enough people who are underrepresented in the workforce and then doing nothing else to help them be productive, pretending that it's enough to just hire people, open the door, that's just misguided, right? That's not actually gonna be helpful for anybody in the long run.
Stu, do you have a question? Because I don't want to open up a complicated topic if you've got something waiting.
Well, I know that, Julie, you've made some recommendations to the New York City task force in terms of how they should adjust their algorithm or use it or not use it. I'm wondering if you could talk about that a little bit.
Yeah, that's a great question. So the Automated Decision Systems Task Force that I was a member of, it finished its work, so I'm no longer a member of that task force. This was an effort that was very highly publicized and that New York City was very proud of, where we were really the first municipality in the United States to attempt to, in quotes, open the black box of the government's use of algorithms, of automated decision systems. The goal of the task force, and the task force was made up of external folks like myself, as well as New York City agency representatives that were appointed by our former mayor. The goal of the task force was to come up with recommendations for city agencies, the Department of Education, Sanitation, NYPD, about how to explain to people, to New Yorkers, what algorithms they use, why they use them, to come up with these governance frameworks, to be able to essentially explain to all of us, right, what these systems do, that they don't discriminate, and to allow us to speak up, to intervene, to participate in this process. Unfortunately, the experience, my experience, and I can also speak for a few others, on the task force was rather frustrating because, and I started this conversation today by saying that I'm a data scientist and I need examples, right? I actually like to understand phenomena by looking at specific domains like employment, which I spoke about. So for the task force in New York City to have made useful recommendations to New York City agencies, we would have had to have access to concrete examples of systems that they already use, or that they are planning to develop or to procure. And unfortunately, the city was very secretive with us. They did not give us any information beyond the very limited information that was already publicly available. And so by the end of this, and I believe this was a year and a half, with fairly frequent meetings and a lot of, just a lot of work, mostly busy work, I felt that it was a waste of time, frankly. And it was also a waste of an opportunity for New York really to show that they are not just going to talk the talk, that they're not just going to say, oh, these are important issues, therefore let's put together a task force, but to also then walk the walk and take a risk and actually sit down with us and tell us, here's what we're doing, we would love your advice. So that environment was never really created where the city felt like they could disclose so that we can productively work together. And I hope that this will change under the new mayor. A new administration is always somewhat of a clean slate. So I'm an optimist, I'm an engineer. We always are optimistic, right? Because we build stuff, we don't just critique stuff. And so I do really hope that the new mayor will be more effective in this type of work.
Okay, we're going to take a brief break, Dave and Julia. This is WHCR 90.3, the voice of Harlem. You're listening to Community and Technology with Dave Burstein and Stu Reid. And our special guest today, Professor Julia Stoyanovich from NYU. We're going to take a break and be right back. Community and Technology. Stay tuned. Welcome back. This is Community and Technology on WHCR 90.3 FM, the voice of Harlem, with Reid and Dave Burstein. And our special guest today, Associate Professor at NYU, Professor Julia Stoyanovich. I wanted to talk a little bit about some of the other areas. I know we were focusing principally on AI's impact on hiring, Julia. I know there are other areas, both in government and industry, where AI is being used and impacting us that is largely invisible to us. Can you give us a sense of what some of those areas are?
Yes, let me actually speak about some of the better areas, some of the areas where AI
is working,
is working, right?
Yeah.
And is working to our benefit, because if it were in fact the case that all we get from AI is harms and potential harms and risks, then the right answer would have been to just throw out the technology, right? Not use it at all. But I don't think that any of us believe this, in all honesty, right? And I, as a technologist, am never going to say that there is no use for these tremendous advances that we have made in data collection, in data processing abilities, in the hardware and in the software. So what are some of the examples where AI is beneficial? Well, first of all, of course, AI is making our lives much more convenient today, right? I mean, it's recommending to us movies to watch and shoes to buy and all of these various, restaurants to go to and eat. And of course, you can question whether these recommendations are opening our horizons, widening our horizons, or are they boxing us in? But be it as it may, there is certainly convenience, right, that we derive from these recommender systems. And in domains like, I don't know, shoe shopping, nothing really terrible is going to happen if I'm shown repeatedly the kind of a shoe that I don't want to buy. And even if somehow automatically the wrong kind of a shoe gets shipped to me, I can always return it and get refunded, right? So the harms are really not there, and the benefit is convenience. Now, we are using AI, broadly speaking, in the medical domain quite extensively. So there is some work out of the NYU Langone School of Medicine, for example, and I am not participating in that work and I'm not affiliated with Langone, where folks have been developing methods for diagnosing different types of cancer, for example, breast cancer, based on images, right? And these AI tools that do the diagnosis, the accuracy that they show is comparable to the best clinicians. And what's even more exciting is that when you have a team of a clinician and an AI working together productively, they outperform either the AI alone or the clinician alone. And I think that this is a kind of an example that we should hold as a kind of a hallmark of responsible AI. So what do I mean by this? What I mean is that, first of all, there's an actual real problem to solve, right? Cancer diagnostics is a difficult problem. And we're not quite there. We are not able to do this with 100% accuracy, right? And every time that you're able to diagnose better, potentially you save someone's life. So there is certainly a need for improvement. Another thing that is really exciting there is that algorithms and data do exist today and are developed even more and more as we move forward, that are able to do a tremendous job at these tasks. And part of the reason for this is that there's a ground truth here, that you can actually check whether the machine's prediction was correct or incorrect. You can get a team of clinicians together, they'll sit down together, think and say, yes, you were right, or no, you were wrong, dear predictive analytic. This, by the way, does not hold in the algorithmic hiring domain largely, right? It's a kind of a self-fulfilling prophecy there. So that's in contrast to the use of AI in these scientific domains where you can actually check using the scientific method whether the thing works or not. Another reason why that's such a productive domain for AI to be used is that clinicians themselves, they are trained in their trade, right? They are domain experts, and they also are trained in medical ethics. So they are not coming at this with this understanding that, oh, if the machine tells me what to do, I'm just going to blindly accept its recommendations. They understand that it's their decision ultimately, and that if a patient is harmed, they will be sued, right? And they'll certainly feel bad, even if they're not sued. So all of these components here, that we have a need to build this technology, that we are technically ready, that we have the data and the algorithms now, and that the human decision maker that is working alongside the machine is well informed and is willing to take responsibility for the correct predictions, but also for the mistakes, is what makes this such an exciting and such a promising case. And I think that as we decide where to spend our money, how to invest our efforts, in what problems we choose to address, what should the smartest scientists be working on? It should be problems of this kind, right? Not self-fulfilling prophecy type work where it really should be a human decision, ultimately, because there is no ground truth. And it's not clear why a system is even needed there.
Interesting.
I actually am really, really startled by the quality of AI. I read the Chinese press every day, 4 or 5 technical websites, because an awful lot of the advances in my field are coming in China. And I'm reading it through Google Translation, which is a creation of machine learning. And it is so good that sometimes I'm not sure whether I'm reading a translation or not. Not always, it's not perfect, but it's gotten really good. And I just discovered that voice recognition works really well. I always wanted to dictate what I was writing, but when I tried the voice transcriptions 5-10 years ago, I guess, it wasn't quite good enough. But I've been working with a program called Otter, as in the animal, .ai, and it is dead on when I dictate to it. And I didn't even have to train it. And you know better than I, what happened in the last 15 years that made machine learning so much better than the AI that I used to look at? You've got some Canadian algorithms, I think.
So, I mean, part of it is really data. That the fact that we have so much data collected and that we are all so comfortable with giving our data, our traces, really, the traces of our lives, of our society, and of our individual traces for processing by these machines, it makes it much easier for these algorithms to learn. But then, of course, there are also tremendous algorithmic advances. So deep learning is all the rage these days, right? Much of this technology, image analysis or natural language processing or machine translation, is based on these very complex algorithms that consume a lot of energy when they run. So that's another thing here to think about, that are used on, that are based on deep learning technology. But really, it's a confluence of things, right? And you say that dictation works really well for you, Dave, right? It's not going to work quite as well for me. And this is because there's a lot more data for native speakers of English than for people with accents. And my accent is not very heavy. I've been living in this country for a long time. But for somebody who speaks with a heavier accent, for somebody who may have a speech impediment, for example, right? These machines are not going to work quite as well. So this is something that certainly simply more data can address, in combination with us being careful when we release these tools to not just report some average notion of accuracy on a typical individual, right? But to also measure and report and improve on the accuracy for a variety of subpopulations.
We actually did a show a while back on that, on face recognition. Stu, do you remember what we heard?
Yes, I do. What we heard was very poor recognition for women of color in particular, that the facial recognition was spot on for white males, and I think for white females as well, but for people of color and for females of color in particular, very large error rates. And I don't know if that's an outcome of not enough sampling, not enough data going in there, or what, Julia? I do know that the folks that make this technology are largely white males, and somehow that bias that gets built in. I don't know how that happens. Maybe you can talk about that a little bit. How does that happen?
I think that in that particular example, it really is mostly data. both that you don't have data that is representative of the broader population that is going to correspond to the actual use case, and also that there isn't a culture of measuring performance with respect to different subpopulations, right? There's usually just a kind of a monolithic accuracy measure that says our algorithm is accurate 90% of the time. Well, guess what? Your data set was 90% white male, and so all the correct predictions were for the white males and all the incorrect ones were for everybody else. There's a pretty famous example of this also from Facebook. This is from several years ago, and they may have fixed this by now, I'm not entirely sure, but to open a Facebook account, you give a name, and the system checks whether this is a name of a real person or it's a made-up name like Donald Duck. And then if it thinks that it's a made-up name, then it's not going to let you open an account. Can you guess what subpopulation was being disadvantaged by this? Meaning they were not able to open accounts? It's Native Americans.
Wow.
And if you report your accuracy overall, you're going to say 99.9% accuracy, but like all the mistakes are in that subpopulation that you're not going to notice because it's just such a small subpopulation in terms of sheer numbers. But it's a clearly a discriminatory effect, right? So these kinds of things we should worry about. Maybe let's discuss very briefly facial recognition, right? Because you would think that this is one of these domains where my conditions for responsible AI are met. Meaning if you have sufficient data, we do have really good algorithms now that we can run on this data. And somebody can in fact tell us, is it a photo of this person or of this other one? So you can validate. There is a ground truth there, right? This is not something that you are predicting and cannot validate. But the issue with that particular technology is not that we can't do it, but if we can do it precisely, then the question is still, what would we use it for? That's good. So the governance frameworks for this, the use cases where there would be benefits to a broad cross-section of the population, they lack. And the dangers seemingly outweigh the risks because the kinds of use that this technology is seeing is in law enforcement, in border protection, and that doesn't warrant the dangers of these systems being used for surveillance, making mistakes in ways that are non-random, like we just said. That risk just does not outweigh the benefits.
Do you know the story about the IRA and their tailor?
No.
This was a classic all the way back on surveillance. I believe it's true, but I don't know for sure. The Domestic Security Agency, which I guess was the FBI, was going after Irish Republican Army in New York. And they had identified 4 or 5 key people. Now, they didn't have a wiretap, but they had the metadata. So they could tell who was in communication with these 4 or 5 IRA people. And they identified a very serious suspect and put under serious surveillance the tailor that they were all going to. Now, I can't swear that's true, but that's the kind of thing that goes wrong. But it's much more serious when you're trying to locate bombing targets in Syria and Iraq. And you've got, in today's times, a picture of 10 civilians being killed. They released the video, and I know a lot of that was because they had very little evidence. They used very sophisticated tools to try to identify their targets, and those tools are just not that accurate. And they're guaranteed to kill civilians.
That's right. And another issue with some of these really advanced tools is that if they are uncertain, very often they won't tell you this. So if a tool is wrong, very often it's just going to be dead wrong. And this is one of the shortcomings that folks are working to correct. But many of these tools don't actually come with a confidence. And then that's a problem.
And you can, as a data scientist, can tell me how the usual measures of confidence are usually worthless. Like confidence intervals, the
Right.
95%. And that just breaks down in the real world with confounding variables, as you were talking about earlier.
Indeed, and then also, for what type of a decision are you comfortable with a 95% confidence? For what type of a decision is it okay to have a 60% confidence? Like shoe shopping, fine, right? But if it's a decision about whom to arrest, I mean, I honestly, this is a domain where, again, I don't think that we are at all in a situation to be using predictive analytics. The criminal justice, to me, is one of these domains where just we lack decision maker readiness. Police officers, judges, they have not been educated in probabilities and statistics. They don't know how machine learning algorithms work. They just are going to be inclined to blindly take their recommendations on faith. And we just can't have that in a domain like this.
Right? We're just got a couple of minutes left.
We do.
Yeah, they just got a couple of minutes left, Dave and Julia. You mentioned education there, Julia. I'm wondering if you could talk a little bit about some of the education around AI. I saw a couple of links that you shared with us about a comic book series and some other learning techniques for young people and others to inform people and educate people about AI. Can you talk a little bit about that?
Thank you for that question. These are among my favorite projects these days. And maybe before I dive into that, I'll have to say that I, of course, came into this space as a computer scientist and a researcher, right? But over time, I understood that the way that we compartmentalize problems in computer science and in engineering, it doesn't work here, really. When you start talking about the interface between technology and society, you do need to take a holistic kind of a point of view. And this is why I've been stepping into these domains where I really don't have a lot of expertise, but I feel like somebody ought to do this. And these are policies, one of them, right? And then the other one, this was based on the realization that all of these decisions have to be made by people. And it's not just some one person, right? Some super smart technocrat that is going to be so well-meaning and so intelligent as to be able to understand how we trade off benefits and harms to employers and to job seekers, and to society. We do need everybody on board in these communications. And I truly, really believe that. I just don't see a way around it. And that's why I think it's very important for us to all get on the same page. You don't need to know a lot of math. You don't need to have a lot of, or any programming experience, honestly, to understand that there is such a thing as data. There is such a thing as an algorithmic system, a system that learns from experience that is encapsulated in that data and makes predictions about the future based on that data. And so I've taken it upon myself to design a course for members of the public. It's called We Are AI. And that I'm hoping to start offering in person, first at the Queens Public Library in New York City, but then hopefully spreading also to other boroughs. And we were planning to do this already in January. Unfortunately, the Omicron wave prevented this from happening, but we're very hopeful that already at the end of March, we will be able to start piloting this course. So this course—
How many sessions is it?
One installment of it is 5 sessions. They are an hour and a half, and you need to come to all 5 because there's continuity in those. And then we will see, how popular it is. I'm really hoping that we will be able to scale this up and to offer concurrent sessions and multiple sessions of this class. The distinguishing feature of the class, the way that it was designed, is that it does not talk about technology first and ethics and responsibility later. I think that it's really important to interleave these from the ground up, because why would somebody care about a classifier? They only care if it impacts them in some way, right? So the kinds of examples that we use in the class are, what's an algorithm? I illustrate the notion of an algorithm with baking, right? So your input data are your ingredients, and then there is some process that you use to mix the ingredients, and then the dough rises, and then you put it in the oven, and then you see whether you like it. And if you like it, you can continue repeating the same recipe. Or maybe you want to try some variety, and then you mix slightly differently, and then you look at the outcome, and decide whether you like that. And this illustrates how you learn from data, right? So these types of things. And then very quickly, we go into some of the domains that are much more controversial than baking and cooking and making chicken noodle soup. And that have to do with, again, algorithms and hiring, or child protective services, or how a facial recognition piece of software is going to work differently depending on whether you're Black or white, and depending on whether or not you wear eyeglasses, for example. Right? So all of these examples are going to, I'm hoping, help people really get a sense for why they should care about this technology, and at the same time, teach them some of the terminology here and really equip them to step up and express an opinion on the design and the use of these tools. And together with this public education course, there is supplementary reading, and that is a comic book series that I really, really like, that I co-developed together with my excellent collaborator, Fala Arif Khan. She's the artist. I cannot produce art, but we worked closely together on this, and I really like how it came out. And I hope that it's accessible to anybody. It does not really require any math or any programming. So please take a look. And
is there a website, Julia, where folks can go look at this material?
Yes, it's dataresponsibly.github.io/comics.
Say it one more time.
Data responsibly, one word, .github.io/comics.
Okay.
GitHub is as in where we put all our programs?
Yeah, it's where everybody puts all their open source stuff, and this is where we put our open source stuff.
Okay. Wow, that's fascinating, Julia. This has been an incredible conversation. I want to thank you for coming and joining Dave and I on Community and Technology. Dave, you have any final comments? We just have about a minute left. Any final comments or questions for Julia?
How good is machine learning?
How good
Not
is
right or
machine learning?
wrong, but whether it's going to get the right answer in many different fields.
It's as good as we make it. I think we need to really be careful to use it in domains where we have reason to believe that the past predicts the future somehow, that you actually have enough information about the problem and where you can check whether the thing works. But for self-fulfilling prophecy, I don't see how it can work. If something smells fishy to you, it probably is, right? So just let's all be well-meaning skeptics in how we use these machines.
Thank you.
Well, thank you. We've been speaking with Professor Julia Stoyanovich from the Department of Computer Science and Engineering at NYU. I want to thank you, Professor, for joining us. It's been a very enlightening conversation. Thank you.
Thank you very much for having me. It was so much fun.
Okay. This is WHR 90.3, Community and Technology on the Voice of Harlem. Stay tuned for more news and information, and be sure to tune in next week, every Wednesday, 5 to 6 p.m.